Hello and welcome to video number 17 in this series. And in this video I'll review some examples of solving quadratic equations using the idea of factoring. So first I'm going to define a quadratic equation as ax squared plus bx plus c equals 0. And here a, b and c are real numbers and a is not equal to 0. And so what it means to solve this equation for x, or to find the roots of this equation, is we want to find any values of x so that the left-hand side and the right-hand side of this equation are equal. And so there's a number of different ways that we can do this, and if we think back to some of the ideas that we explored earlier, it turns out that one useful way of doing this is using factoring. So back in, I think it was video 2, we talked about something called the zero factor theorem, and that said that if we have two numbers that multiply together to give us 0, then either a is 0 or b is 0, or they're both 0. And in video 11, I think it was, we looked at factoring quadratic equations. And so it turns out if we put these two ideas together, we can solve this kind of quadratic equation problem. So as an example, let's work with x squared plus x minus 6 equals 0. And we can look at this and see if we can factor it. That should be our instinct. Anytime we see a quadratic equation, we should think about factoring it if we can. So we need two numbers that multiply to give us minus 6 and add to give us plus 1. And so in this case, if we have, let's see, 3 and 2, and we want plus 3 and minus 2, because 3 times minus 2 will be minus 6, and plus 3x minus 2x will be plus 1x. And so if we reflect back to our zero factor theorem, we can see that we've got two factors that multiply together to give us 0. So either this is 0 or this is 0. For this to be 0, x would be minus 3. For this to be 0, x would be plus 2. So those are the two roots of this quadratic equation, x equal minus 3 and x equal plus 2. We can think of this in terms of a graph as well. So thinking back to the previous video where we looked at representing a linear function as a straight line on a graph, a quadratic function looks like a parabola, which is a curved function. And if we think about these axes here, so this is the x-axis and this is the y-axis, we've got 0 in the middle. This is often called the origin. And then if I mark off, so 1, 2, if I mark off this is 2, and then this is minus 3, because our parabola is going to pass through the point x equal minus 3 and y equals 0, so here, and x equals 2 and y equals 0, which is here. And because the coefficient on x squared is a plus 1, it's positive, it means that our parabola is going to be upward facing. It's going to be a curve like this, and it's going to pass through these 2 points. And the other point that it'll pass through is if x is 0, then y would be minus 6, so it's going to pass through the point down here as well at minus 6. And so the parabola is going to look a little bit like this. So it's going to curve like this, It's going to come down and it's going to dip down below -6 to the left of the vertical axis. And then here it's going to join up like this, and then it's going to keep going up like this. So there's a graph of this quadratic function, and the roots of the equation are where the parabola crosses the x-axis, the horizontal axis, and it crosses at x equal 2 and x equal -3. So let's look at another example, another few examples, to see whether this always happens, whether we always have a quadratic equation like this have two solutions because the graph is crossing in two places, crossing the horizontal axis in two places. We're actually going to see that that's not always the case. So let's do an example of -x squared minus 2x equals 0. So I'm going to factor this. I'll have minus x times x plus 2 equals 0. So the two roots for this equation are going to be x equals -2 or 0. And so we've ended up with two solutions for this example as well. And in this case, the coefficient on the x squared term is negative. So rather than an upward opening parabola, this will be opening downwards. So it's going to be more like a hill than a valley. And it's going to pass through the points x equals 0 and x equals -2. So again, if this is the x-axis and this is the y-axis, and we've got 0, we've got -1, -2, so it's going to cross here, and it's going to look more like this kind of shape. So it's going to be kind of like this. So that's this first example on this side. Second example on this side, let's do 4x squared minus 12x plus 9 equals 0. Okay, so let's see if I can factor this thing. If I have 2x, and then if I have -3, is that going to work? Let's see. So 2x times 2x would be 4x squared, and then -3 times -3 would be +9. And then how many x's do I have? -3 times 2, I've got -6x, and then another -6x, -12x, so I did it. So the other way to write this, of course, is just write this. And so here there's actually only one root for this equation. It's going to be when 2x minus 3 is 0, which is when x equals 3 over 2. So what does this graph look like if it only crosses or touches the horizontal axis in one place? It only touches at x equals 3 over 2, which is going to be here. Then this one, so the coefficient on x squared is positive, so this is going to be more like a valley. And so it's going to look like this actually. Okay, and that's why it only touches in one place, because the bottom of the parabola actually touches the horizontal axis at 3 over 2. So one root or two roots. Is it possible that we could have 0 roots? So let's do a third example. Let's do, so that was, well, let's go back here, and this was example number 1. And this was example number 2. And this was example number 3. Let's do a fourth example. Let's do x squared plus 4x plus 5 equals 0. Okay, it doesn't matter how long I stare at this. I'm not going to be able to factor this. It doesn't factor. But there's a function close to this one that does factor, which would be x squared plus 4x plus 4. So if I write this, then I can see that this is x plus 2 squared, because I got x squared, I got 4x, and I got 4, plus 1 equals 0. So I need to try and make this equal to 0, find a value of x so that this is equal to 0. I can't do it, because x plus 2 squared is the smallest this could be is 0. If x was minus 2, this would be 0. But then I've still got the 1 here, and so I can't get the left-hand side of this equation equal to 0. So this quadratic equation has no roots. So what does it look like in terms of a graph? So it turns out that this one is, when x is minus 2, then the function is equal to 1. So it's got a positive coefficient on the x squared, so it opens up upwards, so it's more like a valley, and it passes through this point here, minus 2 and 1, and it kind of looks like this. Okay, so it doesn't ever cross the horizontal axis. So quadratic equations like this, like in general like this, they either have 2 roots or 1 root or 0 roots. And if you're trying to visualize what that looks like, you could think about these three graphs here. So this is a good point at which to pause the video and work through the next 2 problems that I'll give you and see if you can find the roots of the following 2 quadratic equations. So the first one is going to be minus x squared plus 4 equals 0. And then the second one will be, so that one's fairly easy. That shouldn't take you very long to do. This next one's a little bit more challenging because I'm going to throw some fractions in here. 3 over 2 x squared plus 1/4 x minus 15 over 4 equals 0. And just a hint for this one, pull out a fraction of 1/4 first. Otherwise, you're going to have a heck of a time. Okay, so let's see how you did. So first thing, I'm not super keen on this negative sign in front of the x squared. So what I'm going to do is, first thing I'm going to do is I'm going to multiply both sides of this equation by minus 1, just so that I don't have a negative on the x squared, because that's kind of awkward. So if I multiply everything on this side by minus 1, then it'll become x squared minus 4, and then minus 1 times 0 is just 0. And then now I recognize this as a difference of squares. So this is going to be x minus 2 times x plus 2 equals 0. And so x is either -2 or +2. And once you've got your solution, remember, always check it. So let's plug in -2 into my original equation. So -2 squared would be 4, minus 4 plus 4 is 0. So that's good. And then 2 squared is 4, minus 4 plus 4 is 0. So they both work out. Okay, what about this second one? So I suggested that we pull out a factor of 1/4 before we start, just to make it a little bit easier to work with rather than dealing with these fractions. So if I'm pulling out a quarter in front of the 3/2, then I need to have something, a fraction here, so that when I multiply it by a quarter, I get 3/2. So if I have 6, then 6 divided by 4 is the same as 3 divided by 2. And then for the x, that one's easy. So a quarter times x, and then the 15/4, that one's easy too. Okay, so see if I can factor this thing. So I want to get 6x squared. So one way I can get 6x squared is if I have a 3x and a 2x. So let's start there. So that would give me my 6x squared. And then I'm going to need a -15 from my constants. So 2 factors of 15 could be 3 and 2. Sorry, 3 and 5, not 3 and 2. 3 times 5 is 15. And one will have to be positive and one will have to be negative. And then I need to get just plus 1x. Okay, so let me see. So we're going to have a 5 and a 3. And if I have the 5 here, then I'm going to have 10x. And that would mean the 3 would be here and I'd have 9x. Difference between 10x and 9x is 1x. So I'll put the 3 there. And no, sorry, I said I was going to put the 5 there. And the 3 here. And then which way round do I have to put the plus and the minus? I need to have a plus 1x. So I need to have plus 10x from the 5 times 2. And minus 9x from the minus 3 times 3. And then plus 5 times minus 3 is minus 15. So I think that factors it. And so that implies from the zero factor theorem that either this is 0 or this is 0. If this is 0, then x must be equal to minus 5/3. And if this is 0, x must be equal to 3/2. So I've got 2 roots. One is minus 5/3 and one is 3/2. And let's just check. Let's check minus 5/3 first. So remember, to check I need to go back to my original equation. So I'm going to have 3/2 times minus 5/3 squared. So minus 5/3 squared would be 25/9. And then I've got a quarter times x. So 1/4 times minus 5/3. And then finally I've got minus 15/4. And that is going to have to evaluate to the number 0. So a little bit of stuff going on here. The 3 and the 9, I could do a little bit of cancelling here to be left with 3 in the denominator. So I'm going to have 25 over 6. And then I've got minus 5 over 12. And then I've got minus 15 over 4. And I need to get a common denominator here to be able to add these up. So a common denominator is 12. So 25 over 6 is the same as 50 over 12. And then minus 5 over 12. This is not, yes it is, it's going to work. So I've got minus 5 over 12, and then to get 15 over 4 as a fraction over 12, I have to multiply it by 3, so it'll be minus 45. So now I've got 50 minus 5 minus 45, so I've got 0. So that one checks out. So we check this. And then let's check the 3 over 2. So I'll do that here. 3 over 2 times 3 over 2 squared would be 9 over 4. And then plus 1/4 times 3 over 2. And then minus 15 over 4. So that's going to be 27 over 8 plus 3 over 8 minus 15 over 4. If I want to express that as a fraction over 8, it will be minus 30 over 8. So that equals 0. So that one checks out as well. So that's it for this video, and in the next video we'll stay with quadratic equations, but we'll figure out a way of solving them using something called the quadratic formula, which is something that we can use all the time, but it's particularly helpful when we can't factor in the way that we've been doing.